Okay, so to demonstrate this standard, I have the question here, what is the equivalent resistance of the circuit below? So I just found a random circuit on Google and I wanted to use that and just try and find my way through it. Since the example I found in the book was a homework problem, I believe. So here's this. So I have the circuit written down here, and then I just wrote for in series, you add them together, but in parallel, actually, it is 1 over this here. So, in order to find it, I watched some videos on this because it was confusing me a bit of how to combine the series and the parallel ones, and from what I found is it just kind of keep redrawing the circuit as you simplify it. So that's the route I'm going to take today. So one of the tips I learned is you can take like these two here, that these are in series together, both of these independently, but they're both in series. So you can act like this is one big resistor so this one would be 2 and 2, so you'd get 4, and this one you would get 12. So then you could technically go and redraw this one like what I'm about to do. Like this, and then you can label it again like that. So it's a messy drawing, but it just helps you kind of work through the steps in order to get to the point. It just helps me see which ones are in series and which ones are in parallel. So now this is simplified a little bit. You can see like this one right here, these are in parallel with each other. So to find out what this section is, you can do 1 over 4 plus 1 over 1 over 4. Let me put that in my calculator real quick. You get 2. So these two together equal 2. So once again, you can redraw this like so. Sorry, my hand's shaky. So you'd get 12 here, 4 here. And then, so you pretty much only have to draw 2 squares since you can act like this is one and the same. So right here is where you get 2, and then 10. So, and then again, from simplifying, you can see that these two are in series. So you can add these together to get 12 as they're in series. Because when they're in series, all you have to do is simply add them together. So you can simplify it once again. Let me make just one big square. This one would be 12, and then there'd be one here for 12, and another here for 4. And then once again, you can complete it. You can see these two together are in parallel. So to get this, you would do 1 over 1 over 12 plus 1 over 1 over 12. And I put that in my calculator. Or 1 over 1 over 12. And this gives you 6. So you can see that these two together 6. So once again, you can redraw it here. It makes it a little easier to draw. So you get 4 here and 6 there. And then so you can see these are pretty much in parallel, giving you an answer of 10. So in the end, you get a equivalent resistance of 10 for the entire circuit. And there we go. I feel like this was the best way for me to be able to break it down and really understand where the parallel and series